Alright, so there's something that thoroughly confuses me with how set theory allegedly expands sets of numbers, right? So, like we've seen, like, okay, the natural numbers extend into the integers, which extend into the rationals, which extend into the reals, which extend into the complex numbers. Okay? And so what you get here is there is, within the integers, there are things that are not natural numbers. Okay? So those are the negatives. Within the rationals, there are things that are not integers. Those are fractions. Within the reals, there are things that are not rationals, and those are the irrationals. Within the complex, there are things that are not real, and those are the imaginaries. Okay, so these extra things that we're not noting here, that are not being listed here, the sets that extend these, extend the natural numbers to be the integers, and you extend the integers to be the rationals, right? Those sets that are the extensions are called complements, right? So a nice simple one within the natural numbers, right? You have the evens versus the odds. So the evens are the complement to the odds are the complement to the evens. Put them together, and they give you the natural numbers, and there's no overlap between them. They do not share anything. Okay. But there's a problem, because that doesn't actually work. Okay. And it's interesting that it doesn't work. It's so interesting that it should be commonly mentioned, and I can't find any mention of it anywhere. Okay. So I doubt that I found anything revolutionary, groundbreaking, new that nobody's ever seen before. I always doubt that. Okay. But what I have noticed here is something that I can't find anyone else talking about. And it's interesting. So it should be something that's talked about. Okay. So the natural numbers, when we extend them with the negatives to get the integers, okay, is 0 part of that extension? So here it might sound silly, right? Because you'll say, well, 0 is neither positive nor negative, so no. But there's an argument to be made that, well, the natural numbers shouldn't have 0, or the natural numbers should have 0. So depending on which way you land there, if you say the natural numbers should not have 0, or do not have 0, then when you expand into the integers, you've necessarily introduced 0, because 0 is an integer, but not necessarily a natural number. Okay. But then there's an argument, and there's a valid argument to say the natural number shouldn't have 0, because you don't say 0 when you're counting. Okay. You start counting. The first thing that you say is 1. The act of counting, however, requires establishing a starting point. But we don't say that. We don't say that thing. It doesn't have a name. So, like, that is your 0 point, but you don't say it. So you don't treat it as a number. No language treats 0 as a number natively. So it's strange to include 0 in the natural numbers for that reason. But at the same time, in order to count anything, you have to have a starting point, and that starting point is 0. So it's also strange to not include it. So what is the correct solution? And when we get to integers, which is the expansion of the natural numbers via the negatives, we definitely get 0. So there's an argument to be made that 0 should be negative, or there's a sensical argument there that you can count 0 as a negative. But if you can count it as a negative, you can also count it as a positive. Right? So, is it getting doubled up? What is happening? Do we have a complement? Is this set that extends the natural numbers to yield the integers? Is it a proper complement to the natural numbers, or is there an overlap at 0? I don't know. Okay? Now, with the rationals, it actually gets worse, because there's an infinite number of rationals that yield 0. Yeah. So 0 divided by n is 0 for all integer n not equal to 0. Okay. So the rationals absolutely brings in just an infinite number of zeros that are not the same 0 that we had before, because the way you get to them is absolutely different. Okay. So we've got, the problem has gotten worse with the extension to rationals. Is 0 introduced distinctly by the complement to the integers when we extend into the rationals? There's really good arguments to say no for this one, so I'm not going to... But that's interesting. That's an interesting point. Okay, so then rationals to the reals. The irrationals, now we have a proper complement again, because it's literally just not the rationals. Anything that's real that's not rational is irrational. Boom, proper complement. There's no overlap there. Okay, now how about reals to complex? Okay, so we say that the reals are extended into the complex numbers via the imaginary unit I. Okay. But if we look at the real axis, it has 0 on it. If we look at the imaginary axis, it has 0 on it. 0 is both real and imaginary. How do you do that? Are we reintroducing 0 with the complement to the reals? Or is this an overlap? Is there 2 zeros in the complex numbers, or is there 1? And the problem gets worse, because if you try to take the root of a quadratic that describes a parabola whose vertex is the origin, you do get 2 solutions, and they are both 0, which indicates that there are 2 zeros there in the complex numbers. That isn't, of course, unique to 0 if your vertex is x equals 2. Well, you get 2 2s as well. So, there's that. But, what the hell is going on? Are the imaginaries the complement to the reals within the complex numbers? And if so, how? And if not, isn't that really interesting and worth talking about? And also how? Because neither decision makes more sense than the other. Both decisions feel really wrong. Both decisions introduce paradoxes. What the hell is going on here? This is really interesting. Okay? So, my point here isn't necessarily that I've found something that nobody else has seen. My point here is, why can't I find anyone talking about this? Because this is weird. This is an interesting paradox. Far more interesting than Russell's stupid paradox, or the other paradoxes of set theory, the other famous paradoxes of set theory, which are mostly just stupid. This is really interesting. And I can't see a way that you could fix this. Right? Like Russell's paradox, you can solve with type theory. You can't solve this with type theory because it's actually typing that's causing this problem. I don't know. I've never seen discussion of this. This is amazing to me.